Hi, good day. Welcome back to our class in chemistry. Today, we will open a new chapter that is on chemical bonding and the nomenclature of inorganic compounds. To start with, let us discuss about chemical bonding. Now, what is a bond? A bond is something that holds together. Now, in chemical bonding, the atoms are held together by a bond in order to form a molecule. Usually, this bond is exhibited by those atoms having unstable number of electrons in the outermost energy level. But for those atoms having a stable number of electrons in the outermost energy level, they don't exhibit a bond. To recall, there are two kinds of bonds. One is the ionic bond, wherein there is a transfer of electron or electrons from one atom to the other, and usually this ionic bond is exhibited by the metallic elements. If you are going to recall our lesson on the periodic table, the metallic elements are located in the 1A family, the 2A family, all the elements in the transition elements, and we have the 3A element, and we have the 3A family, and some metals found in the 4A and in the 5A families. Now, these metals usually removes or lose their valence electrons in order to form a molecule. So, for example, the formation of the molecule magnesium chloride. If you're going to get the electronic configuration for magnesium, you will see that there are two electrons in the outermost energy level. So we can say that the valence electron for magnesium is 2. And if you're going to write the electronic configuration for chlorine, you can see that there are 7 electrons in the outermost energy level. So as the molecule magnesium chloride is formed, these two valence electrons of magnesium will be removed or transferred to chlorine atom, since chlorine can attract one more electron in order to stabilize the number of electrons in the outermost energy level. And because there are 2 electrons of magnesium in the outermost energy level, so this will also require 2 atoms of chlorine in order to satisfy the formation of the molecule magnesium chloride. So in this case, the molecule magnesium chloride, which is MgCl2, this MgCl2 is actually the formula of magnesium chloride. Another example of an ionic bond is the formation of the aluminum fluoride. If you're going to write the electronic configuration of aluminum, you can see that there are 3 valence electrons, or you can see that there are 3 electrons in the outermost energy level. And if you're going to write the electronic configuration for fluorine, you can also see that there are 7 electrons in the outermost energy level. So, the 3 electrons of the aluminum will transfer to the 3 atoms also of fluorine. Since there are 3 electrons in the outermost energy level of aluminum, this will also require 3 atoms of fluorine. So the molecule aluminum fluoride we'll have the formula AlF3. The second type of bonding is the covalent bond. In covalent bonding, there is the sharing of electron or electrons between atoms. Usually, this covalent bond is exhibited by the non-metallic elements, except the noble gases, because the noble gases have already a stable configuration in the outermost energy level. A good example of a covalent bond is that of the diatomic oxygen. If you're going to write the electronic configuration of oxygen, you can see that there are 6 electrons in the outermost energy level. Now, since there are 6 electrons in the outermost energy level, it needs 2 more electrons in order to form a stable structure. So another oxygen atom is needed in order to form the molecule oxygen. Now, the 2 electrons of the outermost energy level of oxygen will share 2 electrons of another atom of oxygen, so that there will be 8 electrons in the outermost energy level of one atom, and there will also be 8 electrons in the outermost energy level of the other oxygen atom, meaning there will be 2 pairs of electrons being shared between 2 oxygen atoms. So the structure will look like this. Another example is that of the molecule ammonia. Ammonia is composed of nitrogen and hydrogen. If you write the electronic configuration of nitrogen, you can see that there are 5 electrons in the outermost energy level. And if you write the electronic configuration for hydrogen, there is only 1 electron in the energy level. Now, in the molecule formation, these 3 electrons of nitrogen will share with the 1 electron of the hydrogen. So, what happens to the structure? 1 electron of hydrogen shares with the 3 electrons of the nitrogen. So, it will make 8 electrons now in the outermost energy level for nitrogen. So the structure will look like this. Let us represent this structure by electron dots so that it will be easy for us to locate the sharing of the electrons. Now, what do we mean by electron dot structure? The electron dot structure means the atom is represented by the dots, which are actually the valence electrons of the atom. There are types of covalent bond. Number 1 is the nonpolar covalent bond. This nonpolar covalent bond is formed when there is equal sharing of electrons between atoms, because these electrons have the same electronegativity. A good example is the chlorine molecule. This chlorine, as we have stated a while ago, has 7 electrons in the outermost energy level. So, to form a molecule, there will be sharing of these electrons between atoms. 1 electron of the atom chlorine will be sharing 1 electron of the atom chlorine. So, since there is only 1 electron shared between these 2 chlorine atoms, If you're going to count the number of electrons in one chlorine atom, there will be now 8, as well as in the other chlorine atom, there will also be 8 electrons. So these 2 electrons being shared between chlorine atoms exhibits equal sharing of electrons. Another type of the covalent bond is the polar covalent bond. In the polar covalent bond, this is formed when the atoms have different electronegativities. That means one atom has a greater electronegativity while the other has a lesser electronegativity. A good example is that of the hydrogen chloride molecule. If you're going to compare hydrogen versus chlorine atom, the hydrogen has a lesser electronegativity as compared to chlorine atom. So the chlorine atom will exert more electronegativity as compared to hydrogen. If you're going to write the electronic configuration of chlorine, you can see that there are 7 electrons in the outermost energy level, and there's only 1 for hydrogen. This 1 electron of the hydrogen will share with 1 of the electrons of the chlorine. So the molecule hydrogen chloride has only 1 pair of electrons shared between them. Another type of the covalent bond is the coordinate covalent bonding. In the coordinate covalent bond, the atoms will donate electrons to other atoms in order to form a stable structure. A good example for this is the sulfur trioxide. If you're going to write the electronic configuration for sulfur, you can see that there are 6 electrons in the outermost energy level. Likewise, the oxygen has also 6 electrons in the outermost energy level. Because this is sulfur trioxide, it means that there are 3 oxygen atoms surrounding the sulfur atom. If you plot the electron dot structure for sulfur, there are 6 electrons, or there are 6 dots surrounding the sulfur. And if you also write the electron dot structure for oxygen, you can also see that there are 6 dots for oxygen. Of the 6 electrons of sulfur, 2 of which are being shared to 1 atom of oxygen, while the 4 others will be donated to the 2 other atoms, meaning of the 4, 2 of which will be donated to 1 atom of oxygen, and the other remaining 2 electrons will be shared to the other oxygen atom. So the structure will look like this. Take note that the 2 electrons which are donated by sulfur to oxygen atoms is what we call the coordinate covalent bond. Now, if we're going to represent the shared pair of electrons between the sulfur and the oxygen by a dash, there will be 2 dashes to represent these shared electrons, while 1 dash will represent the donated electrons between the sulfur and the oxygen. So it will look like this. Now, this pair of electrons shared between the sulfur and the oxygen can transfer from the sulfur to another atom of oxygen, meaning these electrons can transfer or rotate in order to form a molecule of sulfur trioxide. So, what are these electrons that usually move or rotate? These are what we call the pi electrons. Now, in the process of rotating or moving from one atom of oxygen to the other atom of oxygen, it can form another structure of the sulfur trioxide. Now, this formation of another structure of the sulfur trioxide is what we call the resonance structure. So, to summarize, the three types of covalent bond, we have the nonpolar covalent bond, the polar covalent bond, and the coordinate covalent bond. So that would be all about chemical bonding. And for next meeting, I want you to read about the VSEPR, which is the valence shell electron pair repulsion, and also about the nomenclature of inorganic compounds. So that would be all for today. This is your teacher, Professor Decitas Ruiz of Holy Name University.